Good evening, my friends, and welcome to ML Ticket. This is Siddhartha Addi, and I'll be taking your session. And today we have an average important topic to cover. It's about custom transformations and feature scaling. Okay, we won't be looking at the full scale of, full extent of feature scaling, but most of the time I'll be talking, for the most of the time in this session, I'll be talking about custom transformation. So this is something which people tend not to do. Okay, I'm telling you right away, but it is a very good process. It's a very good idea to do this thing when you are doing your ML project and later deploying it to some kind of server or somewhere or the other. So it is better to do your custom transformations when you are doing a machine learning project. But now you may ask, Jay, what is this custom transformation? Actually, if I tell you, Jay, we have already done this custom transformation, but I have never used this particular term, custom transformation, then how it will be? Actually, we have done this transformation, but now we are going to do it in a slightly professional or easy way. I won't say easy, but a slightly professional way so that it will help us in the near future. So let me just present my screen and let's get started. Okay, so yesterday we have completed with our categorical values and all, but today we have a lot to say. I have a lot to say about custom transformations. Okay, so what do I mean by saying that we have already done this? Where is the point that we have done this thing? Let me get back to the point where we have done these things. Remember this particular code that we wrote? This particular code that we wrote about if we mix two columns with each other, we can get a uh, higher accuracy. Or what is the term that I used at that point? Do you remember that thing? I said if we sometimes use some of the attributes, now mix up some of the attributes, then we may get greater correlation. As I have said, as we have seen, this particular total rooms, total bedrooms, population, and household is not very correlated with our data. So, and if we try to make up some of our columns, make some of our attributes or features, then we found okay, we may get a greater correlation when we make up these values. But I also said at that point that we are not going to do this right now, and I never did this. Okay, now today we are going to look at a same version but in a different format, in a slightly professional format that people used to do, because this is a very crude and raw format to do this particular transformation. Okay, so what is a professional format that people do? So the if you are not familiar with Python, you may have some problem understanding the code that I'm writing here right now. But if you are fluent with Python, then it won't be necessary enough. So what is the thing that we are going to do? Yesterday, now we are going to extensively talk about this particular fit transform and fit transform methods. Okay. So what is I have already said what are these what things that we can do with this thing. So we already know that Fit actually provides a staging area and trans and applying the transform method transforms our data, and we can do the both of these things in a single method which is known as Fit and transform. So scikit-learn tells us if we can override these three methods, if we can override these three methods, we can create our own sense of transformations. Okay, so we want to create a class. We here actually want to create a class which will do custom transformations. So because since till date we have used transformations over some kind of class that is that we have got from scikit-learn, right? Like like one hot encoder, like these are classes, right? These are classes which are present in scikit-learn, and we are applying those transformation by using these three methods, right? Now we can make our custom our own transformation class, so that we can apply some custom transformations that scikit-learn does not provide, because custom transformation are something uh, which is unique to every dataset, right? So that's why custom transformation is important to learn. To be honest, most of the projects that I have seen or have done, custom transformation is not very much needed. Okay, you are good to go without those without these things. But since I'm teaching you everything from the bottoms up, okay, from the very begin, from the very base, so you need to understand what is this custom transformation. And to be honest, personally I feel that it is very wise to use custom transformations to do our transformation, and so that our um, model runs flawlessly. Now you may ask, Jay, what is the point of doing this custom transformation? We have already done that, right? So why we are doing this again? Because that was a very crude way of doing this, and our machine learning models do not like that crude behavior. So let's just polish this thing a little bit, and let's see what can we get from here. So to do this, I am going to show you two ways. Both of them are almost exactly same, but still. Okay. Okay. So um, we have here. So what I'm doing is, let me just run this cell once. So you may ask, what the hell I'm doing this? This is a so complicated thing that I'm writing, right? I cannot explain you everything unless and until you know a little bit of Python. Okay, I'm telling you that this thing requires a little bit of Python knowledge about list and how for loops work in along with the list. So basically, let me tell you that what is going on in here. I am doing nothing. The code looks fancy, but I'm only selecting the column number. I'm only selecting the column number of total rooms, total bedrooms, total population and households. Let me prove that fact to you. So if I print room x ix, what we get? 3. So total rooms like 0, 1, 2, 3. Yeah. So in that case, total bedrooms is 4, total population is 5, household is 6. Okay, this is what do you say? This is a dynamic way of selecting the rows. You can just I could have just said uh, I could have just said bracket open 3 comma 4 comma 5 comma 6. Okay, I could have just said this, but to be honest, this is a very static way to do this thing. And what I have done this is use a dynamic way of selecting the number of columns. That's all. So I'm going to make a class and name it combined attribute adder, I guess. Combined attribute adder. Okay, and I'm going to use base estimator and transformer mixing. Okay, now one thing that needs to be noted that scikit-learn does not support inheritance. It supports duck typing. Okay, that is you have to write those particular codes by in your hand. Okay, so if you have any problems with what you understand by duck typing, you don't have a clear knowledge of inheritance and all, then I would suggest just Google those stuff. It is nothing much complicated. So I'm just mentioning these things, but to be honest, these are not very complicated. So whenever you declare a class, it is better to use constructors, and that's why I'm going to use constructors, and that's how you use constructors. So I'm going to take a variable known as add bedrooms per room, and by default it will be set to true. And if you don't pass any kind of parameters, it will be set to true, otherwise it will be false. Okay, okay. Now we have to override fit function. Fit function takes 3 parameters: self, x, and y, which is by default set to none. And it only thing it does is return self, nothing else. This particular fit function is same for everywhere. Okay, the main thing that is that we have to do this thing in the transform function. So it also takes self, x, and y, which is equals to none by default. So what are we trying to do? We did, I think, rooms per household. So what is this x? This x is actually we will be passing the what do I say, the data set in this particular x variable. Okay, so we have the x variable here. So since we are passing the whole data set here, so this X contains the whole data set. So we need to what I'm saying here, so we need, what do we need? We need to divide the total rooms, the and divided by the households. Okay, so I am by saying colon, I am saying select all the rows, and select all the rows of which column? I want to select all the rows of the rooms column. Okay, remember we had the column number, and we will be using the column number only. Okay, so I'm dividing it by what I will be it will be divided by the number of households or the households. So I'll be selecting every row by saying colon, it selects every row, and I want the households. Okay, we have it here. Another thing that I think we did is population per household, I guess. Okay, so similarly, selecting all rows, population, and households. Okay, now we, okay, sorry. So what do we have here right now? We need to understand that thing. Yeah, what do we have here? So we have created two new attributes, that is room per household, and another as population per household. Okay, so we know that we have already done this. We have already done this previously, and we have got some correlations. But here what I want to do, I want to add a step which says that either I want to add that particular bedrooms per room attribute, or I don't want to add that bedrooms per room attribute. It should be my choice what to add and what not to add. So I want to create myself with a choice. When I want to give myself a choice whether to add this particular bedrooms per room attribute or not. Okay, now you may argue why I am doing this. You may say that when I am doing I'm creating some new features, I could create as many as I want, right? And I could get our model trained on that. Okay, I agree to that fact. But when we are training our model, if I give myself a choice, then I can just turn this bedrooms per room. This is a boolean value, right? This is a boolean variable. If I just turn this to false, then I can get a particular accuracy score in my model, and then I turn this to true, it will give me, the model will give me another accuracy score, and I can quickly see the difference between the accuracy scores. It will be more easier for me. Other than that, yeah, if I don't do this, I'll have to change the code. I have to hard to change the hard code. I have to come here in this cell and change the hard code and run all the cells again. Now it won't be wise if I have a very large data set, right? It is, if we have a very large data set, then it won't be a wise option to choose. So that's why I'm creating myself with an option, a, whether to add these bedrooms per room. So how do I do this? So that's quite simple. I'm just going to run a if condition. Yeah, bedrooms per room. If it is true, then I want to add. Similarly, I'm selecting all rows and the bedroom column and divided by room, I guess. Yes, I guess it is room. and now I return. Now what do I return? Okay, this is a very important thing to understand. We have to return a numpy array. Okay, why need we need to return a numpy array? Because it is always wise for you to return stuffs in numpy array. Now I always tell people they we get used to this numpy array, because if we have a numpy array we can easily convert that into a pandas dataset, right? This is a pandas data frame, okay, and this is a numpy array, right? So this thing can be easily converted into this thing. There is no issue in that. That is very simple actually. Huh. So it is very important to understand they to get this. We have to get used to the fact that creating NumPy array is easy than creating this data frame directly. Okay, and we can easily convert a NumPy array into a pandas data frame. Now you may ask, why I'm not directly converting it into a pandas data frame? Because converting directly into a pandas data frame takes up lot of CPU takes up lot of computations. Okay, a NumPy array is relatively small than a pandas data frame of that same NumPy array. It is, you have to understand this. A NumPy array is relatively small, and the computation is very fast through an array, very fast, rather than in comparison to this particular pandas data frame. That's why I always suggest people to return whenever you are doing stuff in machine learning, to return stuff in numpy array. It makes our life way easier. You won't be seeing much of a difference if you don't do this, but of course if you'll see a difference when you have more than 20,640 data points. Like if you have 4 million data points, you will definitely see the difference what it's making. Your program will slow down very much at that point. So I want to return, and since I want to return them in a column format, that is, let me just write the code, then then I can easily explain this to you. Okay, so what I've done there, I am returning a NumPy array, and I am concatenating these attributes in a column-wise format. Okay, I am not concatenating these attributes in a row-wise format. By default, if we want to concatenate stuff with in row-wise format, I need to write R. R stands for row and C stands for column. I want to concatenate the NumPy all these attributes into a row, column wise format, because these are individual columns, right? They are not rows. That's why I am doing writing this .c underscore. You can read more about this over the internet if you are interested. But other than that, it concatenates stuff with row wise format. It returns stuff in a row wise concatenated column wise format. Okay, we don't want it in a row wise format. It will be a disaster, I guess. Oh, okay. So we have our if condition, but what if the if condition is set to false, right? Then we have to write another if condition. Sorry, I just want to copy this particular line and going to paste it, but okay, sorry. But we don't have our red rooms per room here. Okay, okay. So we have it. Now I want to I want to apply this thing on the dataset, right? So let me just create an instance of this class. Combined attributes adder, and I'm going to set the add bedrooms attribute. add bedroom but room attribute equals to false. Okay, so I don't want to add this particular attribute, and now we want to apply those changes. How do we do that? We call transform method. Now you may ask the one thing that, okay, we have overloaded fit method, transform method. Where is fit and transform? This is where this transformer mixing class comes in. If we import this thing and add this thing to our class, then it will automatically do that transform, fit and transform stuff for us. We don't need to write that stuff externally. Now you may see me, I am not directly sending the data frame to the particular class. Okay, I am saying the housing, which is a data frame or data set or training data set, and dot values. What this does, it converts our data frame into numpy array and it sends the data. Okay, that's how it is going on, and it is also receiving the data in numpy format, numpy array format. Okay, so let me just run. We have written a lot of code. Let me see. Oh, we have got problems. Of course we need to have problems. uh A does not have any attribute named transform. Of course I have misspelled. Oh, we have we actually did it. Wow. So the code is correct. So this is how you actually make your custom transformation, transformation attributes. Okay, so I have combined these attributes. Now if you want to look at it, let's look at the data. You won't be understanding much of it because it is in a numpy array format. So there you go. Okay, uh, just believe my words that these last two columns that we have got, is the new attributes, that rooms per household and population per household. But you may say, okay, why would I believe your words? I cannot see those things. I want to see stuff in this format so that I can easily comprehend. I'll be getting there, but just for some time, like for 5 more minutes, just believe in this stuff that I am telling the truth, and hold on with me, because we have seen, I have whenever when I was starting to code, I told you that there are two methods to do this. This is the first method. This is the first method to do this stuff, and I am going to show you another method which is very similar to this method, but it takes a little bit less code, and to be honest, it is easier to understand. It is way more complicated because it dives into the oops concept of Python. If you don't know oops concept of Python, it is very unlikely that you would understand this particular set of code. So if you don't have a very good grasp over the oops concept of Python, then I am going to give you an alternative. What is that alternative? So alternative is a function transformer that, and sklearn provides us with a class which is provides us with custom transformer. So it makes our life a little bit easier. We just need to create a function. Okay, we don't need to create any kind of class and then apply this thing, and we just need to create a function. So let me just create the function. Okay, how, what should I name it? Add extra attributes. Okay, features. Let's go with features. cos x and add bedroom, bedroom, and I'm by default it will be true. Okay, so I'm just going to copy this particular code from here, and I'm going to improvise it a little bit. Other things remain same, should remain same. I hope it will work. So let me just create our instance. Now we need to use this function transform. Okay, whatever we did over here, okay, is also been done here only. Okay, this function transformer also helps us to do the same stuff. Okay, and but this is a little bit easier. As you can see that you need to write less code, it is less complicated, so that's why. What is the thing that we want to use? We want to use add extra features. Okay, it takes a parameter which is known as validate, which is set equals to false. Why it is taking this particular parameter? Because we have non-float value, not sorry, we have string values or object type that all, in simple words, we don't have all the values in numbers. Some of our values are in string formats, right? But wait a second, yesterday we did a categorical values, right? So we didn't apply those changes. No, we didn't apply those changes yet. Okay, uh, we will be applying those changes, don't you worry. But since our data set now contains string values, that's why you have to set this particular validate equals to false. You can read more about this over the Google, and I would prefer you to read more on this so that you get a clear understanding. Here also I am setting it to false. Okay, as you can see, the most of the code is same, but I am going to use fit and transform here. Hope that everything is same, I guess. So let's see what happens. Okay, we have a problem. Unexpected indent. Okay. Okay, our code runs fine. If I print this, you will see that we have exact same output as the previous one. If you can see that, I'm going to make the screen a little bit shorter. So if you can just note this particular first row and this first row, you can see that these two values are exactly same, right? Almost exactly same, not completely. No, they are exactly same, right? They are exactly same. So, so we indeed did the same thing, exact same thing, but it took up less space, less code, and it is less complicated. So, still you will say, okay, I cannot understand this particular NumPy array, right? I cannot visualize the data set. I've been used to visualizing the data set like this. I cannot understand this thing. Of course, you cannot. But what I have said, it is very easy for you to convert NumPy array into a pandas data frame. So let's do that. Because to be honest, I have also problems understanding it sometimes. I've done this almost like this is the third time I guess that I am doing this, converting a NumPy array into a pandas dataset. So by this time, if you have practiced, you should know that what parameters that are going to be passed. First parameter that is going to be passed is the NumPy array itself. Okay, so NumPy array done. So next parameter is the columns, I guess. Yes, columns. So what is the columns? What are the columns? We will applying the how we are using the housing dataset, right? So we will be going for the housing columns. But wait, we have some extra attributes, right? So what can we do about that? Because these columns contains only 9 columns, I guess. Most, if I am not wrong. So what about the two columns that we added right now? Okay, what can we do about that? We can what can we do? We can form a list. Okay, let's see whether it works or not. We can do converting this into a list, and I want to add to this list. Okay, what is that? What is the thing that we want to add? Rooms per household. Sorry, and population per household, I guess. Okay, so we are good. What is the next thing? That is indexes. Indexes will be same because we have not added any extra rows, so indexes won't be a problem. So we will be using our old index. And I think that's okay. Let's see. Oh, we did this correct. I cannot believe it. So let's see. The first 5 rows, remember head, it brings up the first 5 rows, and voila, we have it. Look at it. We have our extra 2 columns, we have all the values. Now you can easily understand, okay, now I can believe you that okay, the NumPy array that you were trying to make me you were saying that the NumPy thing is the same as that of the data set. Now I believe you, say okay, indeed, the both the attributes are now added to the data set. Okay, I believe you right now. Okay, it's better for you to believe. Now today we have this is all about custom transformation, but today I want to touch on another factor which is very important. But today I won't be coding anything about that. I'm only going to explain you the concept, and the next day we will be coding that stuff up. Because to be honest, coding it is very easy. Coding that part is very easy. You know, to did not to have, you don't need to do many things. So I'm not showing you that thing, but I will be explaining you the concept right now. Okay, so let's jump in. So the thing that I want to talk about is feature scaling. So what is this feature scaling? You have to eat according to your size, right? So if you are a big man, if you are a big man or a woman, then you have to eat a lot. You have to take in a lot of calories for your body to work. But if you are a thin guy or a thin girl, you need to comparatively eat less, right? And now if you switch the diets of the big guy and the little guy, then it will cause a problem. They will have health problems. In the similar way, we do not want to feed our models with feed our models with data which have different scales. Okay, previously I have always mentioned this problem there, that our data has different scale. That some of our data ranges from 0 to 1, some data ranges from 0 to 1500, some data ranges from 0 to 5 lakh, 10 lakh, some of them 50 lakhs, some data ranges from 0 to 50. So different scales. Okay, but if we input every type of scale into our model, it will start getting confused. It will be getting confused about everything. That's why feature scaling is very important. But to be honest, it's very easy. So one of the most important transformations that you need to apply to your data is feature scaling. Machine learning algorithms don't perform well when the input numerical attributes have very different scales. The types of scaling. There are two types of scaling. Normalization, the value which are shifted and rescaled so that they end up ranging from 0 to 1. This is also known as min-max scaling. MIN-MAX. Min-max scaling. This is also known as min-max scaling. So I don't think I need to explain more about this. It just scales the data between 0 and 1. Whatever the scale of the data can, it can, the data can be of any scale. It will be scaling it down to 0 and 1 within the range of 0 and 1. Another type of scaling is standardization. Unlike normalization, it does not bound the values to a specific range, which can be problem for some algorithms. Now, for some particular algorithms, this ranging up from 0 to 1 is a little bit of a problem. So that's why we use standardization in that place. But it is to be uh, mostly we use standardization only, and we don't go for normalization. But to be honest, when you see the data after the transformation, you won't see much of a change. Okay, you won't be understanding much of the data because it will be squashed down to a range that you won't be understanding at that point. So as feature scaling is a thing that you should be doing at the very last of pre-processing. Okay, to be honest, tomorrow we are going to start with a concept called pipeline, and after that, I think after that we can start with the ML algorithms. To be honest, pipeline is not definitely a part of pre-processing. It's a method that scikit-learn introduced, but feature scaling is we can say that the feature scaling is the end of our pre-processing phase. Now we will be moving into machine learning algorithms and fine-tuning our algorithms. Okay, and when we will be fine-tuning our algorithms, this particular custom transformation that we saw in here will be of very use. This particular custom transformation that we saw today will be of a great significance. Okay, so feature scaling marks the end of pre-processing, I guess. But there are some few things that I need to tell you about, but I'm not going to say these things today because it will be too much for you. And tomorrow we are going to look more stuff on this particular pre-processing, and I think we will be closing with the pre-processing. We are done with the pre-processing, and let's see what happens, and hope you are enjoying this series. And if you have any questions, please ask me, because the point of live session is that you can clear your doubts right away. Okay, so, and of course, if you have any problems, just text me in the WhatsApp, post a question in the group, and I'll be answering as soon as possible. Okay, so uh, so we are done with today. Thank you for attending the session. Enjoy the rest of your evening.